Welcome to Linear Equations Level 5. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving the equation a half multiplied by 4x minus 6 plus 2 multiplied by 3x minus 1 is equal to 5x plus 1. Now to start, on the left hand side of the equation we've got some brackets, so we're going to expand these. So if we start with the left hand one, we have a half times 4x, which gives us 2x, and a half multiplied by minus 6 gives us minus 3, and then onto the second bracket, 2 times 3x gives us a positive 6x, and 2 times minus 1 gives us minus 2. And on the right, we still have 5x plus 1. Now staying on the left, we can simplify by collecting like terms. So we can take 2x and add 6x to give us 8x, then minus 3 minus 2 gives us minus 5, and on the right, we still have 5x plus 1. Now since we have unknowns on both sides, we're going to keep them on the side where we start with the most, and that's on the left. So since we're keeping the 8x's on the left, we're going to remove the 5x's from the right by subtracting 5x from that side, and we need to do exactly the same on the left. So on the left, 8x minus 5x is 3x, and we still have a minus 5 there, and on the right, 5x minus 5x is 0, so we're just left with 1. We now need to remove the minus 5 from the left, and we do this by using its inverse, which is plus 5, and do exactly the same on the right. And on the left, the minus 5 and the plus 5 cancel out to give us 3x, and on the right, 1 plus 5 is 6. Finally, we need to remove the times 3 from in front of the x, and we do this by using its inverse, which is divide by 3, and do the same on the right. So on the left, the times 3 and the divide by 3 cancel out to leave us with x, and on the right, 6 divided by 3 is 2. So our final answer to problem 1 is x is equal to 2. In problem 2, we're solving the equation 4 multiplied by 3q minus 12 all over 3 plus 7 multiplied by 2q plus 1 is equal to 8q minus 1 all over 6. Now since we have multiple fractions in this equation, what we'd like to do is get them all over a common denominator. The bracket on the left hand side isn't a fraction, but we can write this bracket as being all over 1. Now if we look at the numbers 1, 3 and 6, we can see that they're all factors of 6. So we can make all of their denominators equal to 6. So starting with the fraction on the left, we can multiply 3 by 2 to make 6, and this means we need to also multiply the numerator by 2 to keep the fraction equivalent. For the next fraction, we need to multiply 1 by 6 to make 6, so we need to do the same for the numerator, and the fraction on the right already has a denominator of 6, so we don't need to do anything to it. So starting on the left again, and looking at the numerator, 4 times 2 is 8, so this becomes 8 multiplied by 3q minus 12, all over 3 times 2, which is 6, plus 7 times 6 is 42, so we have 42 times 2q plus 1, all over 1 times 6, which is 6. And on the right, we have 8q minus 1, all over 6. Now the benefit in having all 3 of these fractions over the same denominator is that we can now use the inverse of divide by 6, which is times by 6, to eliminate all 3 of these denominators. So we times every term in this equation by 6. And this leaves us with 8 times 3q minus 12 plus 42 multiplied by 2q plus 1 is equal to 8q minus 1. We can now expand the brackets on the left hand side. So 8 multiplied by 3q gives us 24q. 8 multiplied by minus 12 is minus 96. 42 multiplied by 2 is plus 84q. And 42 multiplied by 1 is plus 42. And this is equal to 8q minus 1. Now looking at the left hand side, we can simplify by collecting together the like terms. So we can start by taking 24q and adding on 84q, and this gives us 108q. We then have minus 96 plus 42, which gives us minus 54, and this is equal to 8q minus 1. Now we have unknowns on both sides of the equation, so we're going to keep them on the side where we start with the most, and that's on the left where we have 108q, so we want to remove the 8q from the right, and that means we subtract 8q, and we do exactly the same on the left hand side. Now on the left, 108q minus 8q gives us 100q, and we still have a minus 54, and that's equal to, well, 8q minus 8q is 0, so we just have a minus 1 left on the right. Continuing on the left, we now need to remove the minus 54, so we can add 54 to the left hand side to remove it, and do exactly the same on the right, and the minus 54 and the plus 54 on the left cancel out to leave us with 100q, and on the right, minus 1 plus 54 gives us 53. Finally, we'd like to remove the times 100 from in front of the q, and we use its inverse, which is divide by 100, and do the same on the right, and on the left, the times 100 and the divide by 100 cancel out to just leave us with q, and on the right, 53 divided by 100 can just be written as 53 over 100, or 0.53. So q is equal to 53 over 100 is our final answer to problem 2. In problem 3, we're solving the equation 3 multiplied by y minus 4 minus 2y is equal to 7y minus 9. Now to start, on the left hand side we have a bracket within another bracket. So what we're going to do is we're going to start from the inside and work our way out. So on the left we have 3 multiplied by y minus, and in front of this bracket we actually have a minus 1. So we can expand the bracket by multiplying minus 1 by 4 to give us minus 4, and minus 1 multiplied by minus 2y to give us plus 2y, or positive 2y, and that's equal to 7y minus 9. We can now simplify the terms in the bracket, and we can collect together the y and the plus 2y to give us 3y. So we have 3 times 3y minus 4 is equal to 7y minus 9. We can now expand the bracket that we have on the left, and 3 times 3y is 9y, and 3 times minus 4 is minus 12, and on the right we still have 7y minus 9. And now we have unknowns on both sides, we're going to keep them on the side where we start with the most, and that's the left. So we're going to keep the 9y on the left, which means we want to remove the 7y on the right, and since this is a positive 7y, we're going to subtract 7y from the right, and also subtract 7y from the left. So on the left, 9y minus 7y is 2y, and we still have a minus 12 there, and on the right, the 7y and the minus 7y cancel out to just leave us with minus 9. We now need to remove the minus 12 on the left, and we do this by adding 12 to the left, because that's the inverse of minus 12, and doing the same on the right. Now on the left, the minus 12 and the plus 12 cancel out to leave us with 2y, and on the right, minus 9 plus 12 gives us positive 3. Finally, we need to remove this times 2 in front of the y, and we can do this by dividing by 2 and doing the same on the right, and the times 2 and the divide by 2 on the left cancel out to leave us with y, and on the right we do 3 divided by 2, which we can either write as 3 over 2 or 1.5. And so our final answer to problem 3 is y is equal to 3 over 2.